If you take raw data, a handful of text, some decimal points, a few random numbers, and dump it directly into a Python script, you are guaranteeing a total system crash. Computers possess immense processing power, but zero intuition. They have no common sense. They cannot look at a pile of scattered information and figure out what you want to do with it. They require explicit, rigid structure. To create that structure, we use a variable. Think of it as a labeled storage container inside your computer's memory. We take a specific piece of data, and we use the assignment operator, the equal sign, which grabs the text on the right and pushes that data into the container on the left. You need to completely forget what the equal sign meant in math class. In programming, it does not mean mathematically equal to. It means put inside. And because the container is variable, you can throw out the old ingredient at any time and replace it with something entirely new. Securing your raw information into these named memory containers is the absolute first step. You cannot execute a single line of logic until your data is properly boxed up. But creating these containers introduces a new point of failure. You get to name your variables whatever you want, provided you don't use spaces or special characters. If you try to label a container chef name with a space in the middle, the interpreter gets confused, assumes you are writing two entirely separate commands, and instantly shuts down with a fatal syntax violation. To fix this, developers rely on a strict etiquette called snake case. We drop all capital letters, and we replace every single space with an underscore, snapping it together into one continuous, readable label. This predictable, descriptive labeling prevents the interpreter from misreading your commands. It is your primary defense against terminal fires and logical confusion as your scripts grow larger. So you have a properly labeled container. The computer knows where the data is, but it still doesn't know what the data actually is. This is where data types come in. If your data is a string, meaning plain text, you must wrap it in quotation marks. This strictly tells the computer, treat this as text. Integers and floats are raw mathematical values. Integers are whole numbers, and floats are decimals. Notice how they explicitly drop the quotation marks. This distinction creates a hard operational limit. If you put quotation marks around the number 12, it is a string. It behaves like a sticky note with the number 12 written on it in marker. You cannot multiply a sticky note. If you strip the data down even further, you reach Booleans. A Boolean strips away text and math entirely, leaving only an absolute binary state, true or false. Categorizing your data accurately dictates the physics of your code. It outlines the exact operations the computer is legally allowed to perform on the information sitting in memory. Let's say you inherit a script from another developer. You find a variable holding the value 42. Visually, you can't be sure if it was originally formatted as a plain text string or a mathematical integer. Python provides a built-in diagnostic magnifying glass to solve this. If you wrap your variable inside the type function, the interpreter runs its scan and outputs the exact data class. Seeing str pop up confirms the computer plans to handle that 42 as text. Because you know the interpreter's plan, you know exactly which operations will cause a crash, allowing you to stop the error before it happens. Knowing how to audit, verify, and interrogate the data currently sitting in your system is an essential survival skill. But what happens when the logic demands a calculation and your data is trapped in the wrong format? You have a string 42, but you need to add the number 10 to it. If you try to force them together, you get a type error. The computer panics. It refuses to combine rigid text with fluid mathematics. To resolve this, you use a technique called casting. Casting forces your data to violently change its physical state right in the middle of the script. By wrapping our text inside the int function, we essentially thaw the frozen data. We shatter the text casing, mutating the string into a pliable mathematical integer that the computer can now process. Casting allows you to bend raw data streams to fit your logical requirements. You dictate the data's behavior, not the other way around. When you pull all of these pieces together, the system stabilizes. You can assign a customer's name to a string, calculate their bill using floats, and check if they paid using a Boolean. You can then use an F string to seamlessly embed those dynamic mathematical variables directly into your final text output. The raw data injects right here, creating a perfectly formatted restaurant receipt. The chaotic, crashing void of unstructured numbers and text from the beginning is gone. The interpreter knows exactly where every piece of data lives and exactly what it is allowed to do with it. Writing code is the deliberate management of data. Building this foundation of tightly labeled, properly classified data structures is the prerequisite for all advanced software engineering.